The nervous system is broken up into parts. You got to know all the different parts of the nervous system. By the way, how many spoke to Miss Marino about taking the AP exam? Would you please do that if you're going to? Why am I doing this?
I don't know.
It's good exercise.
Can
we go take a field trip down there and ask her? Right?
Absolutely not. Just go right after school. She'll want to talk to you. There's the brain. There's the spinal cord. That makes up your central nervous system. If you look at the cells in the brain and spinal cord, they're actually different from the cells in the rest of the nerves, the rest of the nervous system. So the central nervous system is not only a different assignment that we give it, the cells are actually different. The peripheral nervous system is everything other than the brain and spinal cord. All the nerves that send messages to and from the brain that do not include the brain and spinal cord. That's the peripheral nervous system. So we call them the CNS for central nervous system and PNS for peripheral nervous system. Now the peripheral nervous system is divided up into two main groups: the somatic nerves and the autonomic nerves. The somatic nerves are under our conscious control. They go to muscles mostly that you can control. It also comes from the parts of your nervous system from the when you touch something, the signal comes in to the central nervous system. What you can feel comes in through the somatic nerves. The autonomic nerves go to the organs of your body that are not under your conscious control, your internal organs, such as your liver and your spleen and your heart and your digestive organs. All of that is under autonomic control.
You said ninjas can...
Some 1 in a million people have an overlap between their somatic and autonomic system, and then thus can control their autonomic nervous system. And some of those trained as ninjas, like me. Although I'm not really allowed to tell y'all that, since y'all are friends.
It's on camera now, though.
No.
You think it's on camera. Ninjas can erase cameras. So, you have the, here's kind of an overall diagram, which you should probably know. It's on page 113 in your book. You have your central nervous system, that includes your brain and spinal cord. You have your peripheral nervous system, that includes your autonomic and somatic. The somatic system controls your muscles that you can move just by thinking about it. Your autonomic nervous system controls all the glands and blood vessels and internal organs, stuff you can't think about. Now, the autonomic nervous system is actually broken up into two groups: the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system is your fight or flight. Have you ever heard of that, fight or flight? If you get scared, you know, you hear a real loud sound. Bah! If you jumped a little bit there, that was your sympathetic nervous system controlling that. See, your sympathetic nervous system is always waiting for a surprise. And when it senses something that's a surprise, it sends signals very quickly to a bunch of organs that get you ready for fight or flight. Fighting, like I do, or running, like y'all would do in that same situation. So that's sympathetic nervous system is action. And I always used to remember I have sympathy for someone who is scared. That's how I would remember it. Parasympathetic is the energy conservation part. It sends messages to all your organs to slow down. Everything's calm now. Parasympathetic is active when you're tired. And I always used to think of a parachute. Goes lazily down. I don't know. Just the way I would remember it. You can think of it however you want. But those two, the parasympathetic and sympathetic nervous systems, are opposite one another. One of them gets you ready for danger, one of them gets you ready for sleep. And so they kind of go against one another. At any one time, one of them may be more active in your body than the other. But they aren't both active at the same time. So that's the autonomic nervous system, has those two systems. So there's a lot of central nervous system, peripheral nervous system, somatic nervous system, autonomic nervous system, sympathetic nervous system, parasympathetic nervous system. There's a lot of different systems here. You can imagine several multiple choice questions. Multiple choice? Test? Questions? Maybe? No? Voice getting higher?
Give a shout out.
Alright.
World star.
Already talked about all this. There's actually part of your spinal cord, the parasympathetic division comes off of the top of the spinal cord and the bottom of the spinal cord. That's where the nerves break off to go to your various organs. The middle of the spinal cord is where the nerves break off to go to your sympathetic system. So this kind of just shows everything that happens if you get scared, for instance. Your pupils dilate. Your sweat glands are stimulated. Your heartbeat is accelerated. Your bronchial tubes in your lungs open up. You increase epinephrine and norepinephrine secretion. Those are hormones that get you going. It relaxes your bladder wall. That's why sometimes you pee your pants when you're scared.
How do you? I thought you. Never mind.
What?
Why does it do that?
Well, if you go back to your wild animal days, if you get a wild animal in the corner and it's threatened and it gets real scared, if it all of a sudden pees itself, that's the little defense mechanism, because all of a sudden the attacker has pee all over them. And it also relaxes your sphincter muscles, and so you crap yourself too. And so all of a sudden you're going after this animal and it pees and craps itself. Maybe you don't really want to be messing with this animal. And so we retain evolutionarily some of that.
It's deep, man.
And so if you're really scared, you might crap your pants or pee your pants. And that's kind of a whole different.
What happened to me once again?
You'd have to be really wanting to hurt the animal if you're going to keep going after it does all that.
Speaking of pressure, we need you.
Oh.
McLean, you're needed. By Eli.
Eli. Hey.
Who's that?
We'll be right.
Eli?
After these.
What's she doing here?
Okay, I'm going a little bit into the next section here, but not too far because it's a very long section, and to read it in one night may be a little rough for you, and for me to talk about it all in one day is a little rough. So I'm just going to say a few things here about the nerve cells. Nerve cells are called neurons. Here's a neuron, and you can see how they look. They have, this part's called the cell body. Let's see if I have, yeah, here we go. This one's labeled. We have this part's called the cell body, and then it has these little things that look like trees or antlers or branches. They're called dendrites, and they receive signals. They increase the surface area of the cell body so lots of signals can be received. And then there's a long extension called an axon. They can be very long. There are axons that run all the way from your brain all the way down your spinal cord. So some axons can be that long, but they're real thin. You know, if I had one sitting here waving it in front of you, you wouldn't even be able to see it. It'd be so thin, but it's real long. So you have your axons and your dendrites and your cell body. That's the major part of a nerve cell. And then the axon is often covered with this yellow stuff that's called myelin. And myelin is like insulation that wraps around your nerve cells. And it keeps the nerve signal in so that the signal moves very fast. Because of this myelin, a nerve signal can propagate at several hundred miles an hour. And so if somebody touches your finger, a message goes up real fast through a long axon to your spinal cord and then to your brain, and it gets there in just a split second. So it feels instantaneous to you, even though there's actually a delay from the time someone touches you to the time you feel it. There is a delay, and that it can be measured, but it's hundredths of a second, tenths of a second, very, very short delay. So the axon is very long, and here this nerve cell is touching another nerve cell, and the ends where one's nerve cell touches another one, there's a junction called a synapse, and that's how your nerve cells communicate, is through these synapses. If you look up close at a synapse, there's actually little chemicals that are squirted out that come from one nerve cell and are squirted onto another nerve cell to allow the communication. And it's those little tiny chemicals, they're called neurotransmitters, that are really important to how the nervous system works. And we're going to talk more about those. But see, since nerve communication is of a chemical nature, that means we can stimulate or depress the nervous system using chemicals. Like you do on the weekend. Last night at the Super Bowl party, you were probably drinking alcohol. Alcohol is a chemical that can depress the nervous system. It's a nervous system, what's the word I'm looking for? Depressant. There are chemicals that are nervous system stimulants. So we'll talk about that, but it's the synapse is where the chemicals go from one neuron to another for the stimulation of the next neuron. You can see how the end of this axon here branches off into many branches before it stimulates the next neuron. And there are disorders where the myelin sheath starts to wear away and communications start getting lost or crossed, such as Parkinson's disease and other things like that. Problems with either the stimulation of the neuron or with the myelin sheath or crossing of the signals. All sorts of nervous system disorders can happen. And once you understand the neuron itself, we can then talk about those disorders in more detail, which we're going to do later. Hold on, I'm going to go back. Your nerve cells, here's some nerve cells that are in the brain of a newly born rat. And they cut open his brain and looked at the nerve cells, and after 3 months and 6 months and 15 months of life, there are a lot more connections between nerve cells. We call these connections synapses, where one nerve cell grows a connection to another. And we know that the formation of these synapses has something to do with learning. When you learn something, I'll tell you my last 4 digits of my Social Security code, 1902.
Want to write that down?
You can if you want. 1902. Remember that? Well, if you learned it, you have somehow formed synapses between neurons that somehow allows you to learn. The more learning you do, the more synapses you form. I don't know if that'll stay in your brain, but
19 what?
02.
Okay.
And so you may have formed, if you remember that, we'll see if you remember it tomorrow. If you remember that, you form the connections.
So if you forget it, you lose that connection?
That's right. The connections can be lost. and you can forget.
What makes one stick?
That's a good question. They don't really understand exactly how it works.
Wouldn't be forced to connect to the all synapses?
Gotta be in the classroom
I don't know.
doing this one.
Here's a rat kept by itself in a cage with no other rats or anything to play with, no toys in there or anything. You see, it has a lot less developed synapses, less connections. This is a drawing of a typical neuron from the brain of a rat who was in a cage with a bunch of other rats and little toys and stuff to play with. Lots more connections. So they're learning a lot more when they have more stimulation than if they had less stimulation. Okay, so make sure you read tonight, at least read pages 109 to 112, or 113, I guess. And then tomorrow night's reading is going to be a lot more. So if you want to do a few extra pages, 114, 115 or so, then you can get to where we talked about today.